So I wanted to get on and do a real short video on complex numbers, imaginary numbers, and that way I can leave you a lesson on just working with operations with complex numbers before we start using them with factoring. So remember that complex numbers can be written in standard form, and that looks like a plus bi, where the bi would be your imaginary part and the a is your real part, and that's what makes up a complex number when you have a real part and an imaginary part. Don't forget also that I is what we call the imaginary unit, and it's equal to the square root of -1. And then we also need to know that if I is equal to the square root of -1, then I squared is going to be the square root of -1 squared, which would be -1. So let's look at a couple operations with complex numbers. Let's start with addition and subtraction. So if we were going to add complex numbers, then when we add the complex numbers, what we do is we add the real parts. So 4 plus 7 will be 11. And then we add the imaginary parts. 3i minus 5i would be -2i. When you subtract complex numbers, what I normally do is I just change them to addition. So if you have 5 minus 7i minus the quantity 3 minus 6i, I would change this to plus and then change all the signs after that, because subtracting is adding the opposite, and then do the same as you did with addition. So add the real parts. -5 plus -3 would be -8, and -7i plus 6i would be -i. And one of the things you're going to want to make sure you do is write your answers in standard form when you complete your assignment. Now let's look at multiplying with complex numbers. So say we have -5i times 3i. Well, you're going to multiply like you normally would. -5 times 3 would be -15, and I times I is I squared. But now if you recall, we said that I squared is -1. So every time you see an I squared, you're going to replace it with -1. So that's 15 times -1, which would be positive 15. Or if we had something like 6i times 5 minus 4i, in this case, we're going to distribute and then follow our multiplication. So I would have 30i and then minus 24i squared. But again, we remember that I squared is -1, so that's 30i minus 24 times -1, which is actually 30i plus 24. But we want to rewrite that so that we're in standard form, so it would be 24 plus 30i. One last multiplication problem might look like this. So say we have 4 plus 2i times 6 minus I. Well, now we're multiplying a binomial times a binomial, so we would FOIL this out. So I'm going to get 24 minus 4i plus 12i, then minus 2i squared. But again, recall that I squared is -1. So we're going to have 24 minus 4i plus 12i, but if we put in -1 for I squared, that makes that plus 2. Now combining my like terms, I'll have 26 plus 8i. Then the last thing we want to do is we want to wrap up with dividing with imaginary numbers. So say we had 2 over 3i. Well, if you recall, when you're working with square roots, you're not allowed to have a square root in the bottom of a fraction. Well, I is a square root. It's the square root of -1. So we're going to multiply the top and the bottom of this fraction by I to get 2i over 3i squared. The reason I do that is that's going to allow me to now get rid of the I squared and put in -1. So I get 2i over -3, which could be written as -2/3 I. If we had 3 plus 5i over 4i, I could multiply top and bottom by I, and that's going to give me 3I plus 5I squared over 4I squared. But again, that would simplify to 3I, but I squared is -1, so that becomes -5. I squared on the bottom is also -1, so that becomes -4. So that's -3/4 I plus 5/4, because -5 divided by -4 will be +5/4. But in standard form, you rearrange that to 5/4 minus 3/4 I. One last problem. Let's say we have 3 minus I over 2 plus 4I. In this case, when the denominator is a binomial, what you're going to do is you're going to multiply by what we call the complex conjugate. And what you do to get the complex conjugate is you just take your binomial and you change the sign in the middle. That's the only sign that changes. So 2 plus 4I would be 2 minus 4I for its complex conjugate. So I want to multiply top and bottom by 2 minus 4I. So I'm going to distribute on the top, or FOIL, and get 6 minus 12I minus 2I plus 4I squared over, then when I FOIL on the bottom, I'm going to get 4 minus 8I plus 8I minus 16I squared. So the nice thing that happens when you have complex conjugates is your outer and inner terms will always cancel. So really all you have to do is multiply the 2's and the 4i's. You multiply the first terms and the last because outer and inner will cancel. Now if you don't remember that, you can always just multiply it out completely. So if I recall now that all my I squareds are -1, then that's going to leave me with 6. I'm going to go ahead and put my i's together. So minus 14i minus 4. 4 times -1 will be -4 over 4. And then -16 times -1 will be +16. So kind of cleaning this up a little bit, I get 2 minus 14i over 20. But then I'll split that up into 2 over 20 minus 14 over 20 times I. But that's 1/10 minus 7/10 I. And you're in standard form, so that would be your final answer.